cut a little bit, like, my precious.
Changing a lot in my world picture.
Yes, you should.
Data, Anton, you forgot the data.
Deployments are not sexy. The scalability is not sexy.
I forgot.
Hi.
So, first of all, let me introduce our guest, Roma. Roma, we're introducing you. Maybe a couple of words about yourself.
Hello, my name is Roman, and how many words do I have? Like, what's the budget?
You ran of the day.
Oh, already. So yes, I'm Roman. Bye.
The funny thing is, that's our second episode, and the name of the guest of the first episode?
Also Roman.
Yes.
I guess it's like a criteria how you choose people to join. So the third episode should be also with Roman.
Yeah, that gets a bit challenging, but we'll try, do our best.
I know a couple of Romans I can introduce you.
Okay. Yeah, please do. Right. So look, on a more serious note, not sure how much more serious though, we're going to be talking about LLMs today, right? Also with a twist. If things go well, we might talk about LLMs in the next episode as well, and the episode after, because we are kind of trying,
to find a person with the name Roman who knows something about LLMs.
That as well, yes. But to be a bit more specific, today we're not just talking about random LLMs, but we're going to be talking about LLMs when it comes to search, because Roma just randomly happens to be a Roma and also an expert. I guess we can call it an expert in the search field, right? And also by the means of your professional life, you, I guess, had your share of working with that. With LLMs in search, I mean, is it fair at all? Maybe you can give us a bit of a hint on your...
So I'm working in the search industry for long enough. You sit on the near the river and see dead bodies of technologies floating around you. So when you saw enough of them, you can consider yourself an expert, probably.
Okay, that's fair.
So just a question, like basically sitting on the river or branch and waiting for technologies to die. This is a way for search development right now, yeah?
Yes, so probably something else was going to be invented in a couple of years. Because in search, as in any area of machine learning right now, everything changes quite rapidly. So some technologies were like, embeddings. 2 years ago, it was like, whoa, such a wonderful technology. And now it's like MongoDB has embedding support. Oracle has embedding support. Now it's not something wonderful. You can impress people on a date.
It's actually a good cue, I guess, into the first topic. So I assume there are a lot of people who are familiar with LLMs by now. I mean, it's hard to not be familiar with LLMs, right? And depending on your technical level, you might have a different level of understanding. But nevertheless, I think search is something, slightly controversial. I believe if you ask a random, even a random engineer, of how you think the LLMs are applied to search, they will start with, probably you can do the query expansion, probably you can fix spelling errors with LLM. So basically, the first thing that comes to mind, let LLM translate text and then do something, right? But I guess it's also fair to say that it's not exactly why we use LLMs for search, and it's not exactly the main benefit that it brought into the search, right? So what's in there? Why we are at all talking about, you mentioned embeddings and stuff like that? Why does it matter for search? What's the general idea behind that?
I guess the idea, it's more like a historical artifact right now, but most of the models we use now for search are based on on BERT model or some variations of an good old BERT model from 2017. And modern LLMs are not like BERT and more modern architectures, like just an encoder only, but what you see on ChatGPT. So historically, like, very different. And I guess the difference is that with the good old BERT model, they were quite bad at generating text. So if you can ask BERT to generate text, but it will look absolutely creepy. But if you use it for search, like translate a text into numerical representation and search over that, the results were quite good originally, even in 2019. So I guess the search industry is a bit more used to using LLMs and deep learning models for search than, and ChatGPT took everyone by storm in 2023. But as a person who is in the search area for quite some time, I saw that it was all coming. But in search, embeddings are like much more older technology than ChatGPT.
Right. Well, that's fair. Okay. And you said BERT is still in good standing when it comes to search, or it's
surprisingly? Yeah, I think I can make some sort of an intro how all this search works. Like explain me like I'm 5 style of explanation.
I like 5, yeah.
So a long time ago, there was lexical search. You have a document, you have some keywords, you search, you have a search query with a keyword. If the document has this keyword, it's a match. The issue is that if you're searching for something not exactly matching, for example, you're searching for pineapple and someone uses the word ananas, like the whole world, non-English speaking world, or you're searching for vegetarian, but this is vegan, so they are very close but not completely the same term, you might need to have some sort of a semantic relationship. So you can, in old good days, we all used synonyms manually entered into your search engine, but some time ago there was a first iteration of all these embeddings with word2vec, when you can translate your text into a numerical representation. It was a statistical model, not even neural network, but it was still working well. And there are examples coming from there that if you have an embedding for a word queen and have embedding for a word man, and you subtract man from queen, you get a king, which was a nice property of this type of embeddings, but it's not gonna work well for sentences because, like, what you wanna subtract off, so it's not like a mathematics here. But then neural networks came, the transformers, and it was just a different reinterpretation of the same idea. So you can translate. So originally transformers were translation models. So they eat text and emit text, probably in different languages. But in the middle, there was some intermediate representation, this numerical embedding representation. And this representation still had this nice properties that similar sentences had similar embeddings. So people were thinking, why don't we just use it for search? And they were working kind of okay. You can take BERT embeddings in a modern vector database and search, and it will even work. But it's not going to work perfectly because it might get you some obscure search results. And also some time ago, as neural networks are meant to be trained on downstream tasks, someone decided, why don't we just teach neural networks to do search? So our main goal is that if you have a search query and a relevant document, their embedding should be close. Usually it's like a mathematical operation. You took a cosine distance in some space, but anyway, you have just a similarity. So they're close, and they should not be close with a relevant document. So that's the target. If you have a large enough data set, you can just train it to make it work well on search. So relevant documents gonna be closer. This is how this sentence BERT and sentence transformers were born. And I guess that changed the whole industry. And the paper of sentence transformer was 2019. So people decided that you can not only use lexical search, but also embeddings for search. But all the search engines were not really able to do this. So you cannot put embeddings in Elasticsearch in 2020 and even 2021 and 2022 because they were like, these kiddos are playing with embeddings, were big and huge. But then there were a couple. So it was more like an academical mental gymnastics of doing search in a novel way. But in a couple of years, then there were a couple of databases written for this type of search with nice demos. People were impressed. These databases became large VC-based companies right now, like Qdrant, VV8, plenty of them. And currently, a lot of different legacy search engines like Elastic, open source, Solar, whatever, they're trying to also have it. Even MongoDB, even Oracle now has vector search. Should you use Oracle for vector search? Unlikely, but you can.
Fair. I'm sure we'll touch on the databases later, like properly, right? But I just have like a few questions regarding the embeddings, if that's fine, to clarify for me and maybe part of the audience. So that first of all, you mentioned this nice property of embeddings of similar words or phrases or sentences being close to each other. Is it a byproduct of how the models are trained, or they're specifically trained to mimic? It's like how does it work? Like, it's not. It doesn't seem to be like a natural property if you just map text into numbers, right?
So this transformer model is trained to fill the gap in the sentence, and that the issue that it's a byproduct of like a side effect. So these embeddings are similar. Original BERT was not trained for search, but embeddings are similar. It's just a nice observation. And people decided just to push it further. Okay, we haven't trained for this particular property, but what will happen if we do? And nowadays, there is a separate piecing competition called MTEB Benchmark, a leaderboard, where everyone is trying to get the best ever number to say that they have the best ever embedding in the world. Even I once tried to submit there, but I found out that my embedding is number 50, and I decided not to submit.
That's not bad. I mean, 50 in the whole world, right? It's not 50,000.
It was like 1.5 years ago. It was 50 out of 100, so kind of.
Okay. Well,
not impressive.
That's a median, right? So that's what
like average Joe.
Yeah.
So just a small comment from my side. Like, am I correct to tell that like embeddings for search is a kind of like penicillin, which was eventually developed? So it was not an intention to get it, but somehow someone decided, oh, that's nice.
I got the impression that whole this neural networks industry coming from attention is all you need paper was like just not intentionally provoked by Google. And they someone mentioned from Google, so if we knew the consequences, we will never publish this paper.
Kind of makes sense, right?
Yeah. Okay. Because you're like having a brilliant and you can share it with everyone, or you can just keep it and breathe like, my precious. And because if you're Google, you might get a couple of extra trillions on that.
Oh, yeah, definitely.
But also like market creation could be seen as well. Tesla gave all the patents to be able to get a share, a part of the market.
Right? And then think about the markets. So it's only fair. Okay, my last question on the embedding topic, because I believe you're like overthinking it maybe. But so as far as I understand the embeddings, it's essentially like a long array of numbers, usually like floats, right? That let's skip 1-bit LLMs and everything aside. So how big is generally this vector? I mean, in size, just a range, to understand what we're dealing with.
So it depends on who is gonna define the average. So in academia, if you go on these leaderboards, it's all couple of thousands, usually 3 to 4 to even 8. But it's not yet practical to have it in production, because usually huge embedding size assumes that you have a huge embedding model and you need to run it. So when you do search, you can embed your documents offline, and it's kind of one-off task. You do it offline, you put them in the index. Sometimes you incrementally write something there, but not that much, and still offline. But for queries, it's another story. You need to embed it in real time. And if you have a multi-billion parameter model, embedding it might take some time.
Right.
And I guess it's also expensive.
Expensive, yes.
Yeah. Well, yeah. And I guess the size of the embeddings, as in like the physical size of being whatever, like a couple kilobytes to couple dozens of kilobytes, doesn't really matter, right? I mean, nowadays it's not terrible.
Yes, so it's still reasonable. It depends on your data set.
The data set, obviously, yeah.
So for example, in the company I work for, we have not a huge data set, like tens of millions of documents, so reasonable amount. But still, if you have embedding taking like 5 kilobytes each, so it can be just tens of gigabytes, and it can be a little bit costly just to keep it in RAM. But it's all a matter of costs, and not about the embeddings itself, but about computing this embedding. So then you need to do this inference for documents. It takes some time. This giant multi-billion parameter models might take you 1 second on a GPU to index a document. This is not a nice latency already, even on modern hardware.
Right. Okay.
And search comes with its limitations, as far as I understand. Like if you are talking to ChatGPT, you will be forgiven it to be slow. But if you are doing fuzzy search or some kind of autocomplete, you expect it to be blazingly fast. So you cannot simply get bigger to be better.
Yes, and usually, so especially in e-commerce, there is like a city legend of Amazon or in Google that 1 millisecond cost them some random big amount of money. We did some sort of it's not like, as I'm working in an e-commerce search company, we also have quite a large historical data set of transactions and all this backend tracking information. So I once just joined it with latency and transaction history and made my own research. And yes, there is like a slight correlation. It's not linear, it's not exponential, but there is still like a slight increase, like slight decrease in conversion rate if you increase latency, but it like looks like a plateau at some moment. So when it's fast, it's nice. When it's lagging for a second, you don't like it. But if it's lagging for 2 seconds, it's kind of doesn't matter much. It's already too slow for you, so you just sit and wait for a second or for 2. That's doesn't really matter. Yes, maybe beyond 2 seconds, we don't have that much information for this type of latency. We're trying to be faster than it. But yes.
It does remind me that correlation between the application size and cost of acquisition. You can obviously imagine if the app is, the mobile app, is like too big and takes like hours to download, obviously it's going to be harder to acquire users because, they have to wait. But apparently there is almost like, I don't know, linear, hyperbolic, whatever correlation, even in smaller sizes, because of connection speeds and whatever, right? And 10 to 20 megabytes might not be a big difference for you, but for someone on 3G is a big difference. I guess it's roughly the same here. Not everyone churns after a second, but the chances of people actually closing the tab or whatever just get higher. And that's very bad.
Now, there is also, in practical search, it's not only computing the search query embedding and retrieval. There is also usually a third stage called re-ranking. So the goal of your retrieval is to select top, 100 documents which are relevant for your query, but out of tens of millions. But you need to do it fast. So you're limited in all the smart things you want to do while retrieval, because you need to score through like 10 millions of documents. But if you have top 10 or top 50 or whatever, but just top documents, you can also run them through yet another algorithm, which is much smarter, but can only work on a limited amount of documents, not on a million, but on 10, it will still be within your latency budget. And in practice, usually this is a much smarter machine learning model, which usually takes into account transaction history, personalization, all this blah, blah, blah. It might take like 50 to 100 milliseconds. So and in some cases, you might also need to do something else beyond doing search. Right. So in Google, by the way, usually they also have this layered architecture of searches. So they have, how it's called, like boosters or boosts or something like a post ranking features which are shuffling your search results in a specific way, like okay, we want to manually boost new documents a bit higher and so on. So usually also in practice in e-commerce, you also have some sort of a business logic happening even after ranking. And as I work in a company also doing food delivery, there might be some ad-related activity after that, or maybe some promotions or some post-filtering based on availability. So a lot of different things happening. Searches, maybe if you're just doing search on the website, you don't do anything out of that. But in e-commerces, usually you do. So the latency, so search is not the only thing. And like adding extra 500 milliseconds just for the sake of better, bigger embedding model might cost you more than you will get with conversion increase.
Right. So you basically need to optimize the whole instead of optimizing all the parts.
Unfortunately, yes.
Theory of constraints works perfectly well for that as well.
Look, you mentioned that we are like limited to doing not so smart things during the search phase, and we can do smart things later, right? But I guess it's worse than touching and defining what smart thing is, right? So for one, we already kind of get a very smart thing of finding bits that are semantically similar, right? You look for, I don't know, whatever, a dog, and you get everything that is dog-like, right? Or whatever. But what else comes out of the box for free? What doesn't? I mean,
but relevancy is not objective thing. So what is relevant for you might not be relevant for me, and that's relevancy is subjective for persons. So there is personalization, and even for like a company. So you're searching, you're selling food, for example, like the company I work for, so I'm expert in this stuff. So you search for tomato and you got ketchup in your search results. Is it relevant or not? That's like a quiz.
It depends, right?
It depends, yes. But what do you think? Is it relevant or not? Yes and no?
For the food company, I would say probably no.
I also vote for no.
Yeah.
Yes, you're right. But if you see the actual customer behavior, see that if you search for tomatoes, you almost never buy ketchup. But from semantic similarity perspective, these things are semantically very, very similar. So that's kind of a popular glitch of our couple of first versions of embedding models, which were struggling from that. Because there is also a context of your customers, what they do expect to see in the search. Maybe if you're searching for ingredients, I don't know, maybe would be okay that tomato is made of ketchup is made of tomatoes, but there is some sort of a company-wide context there and a personal context, so it's very hard to define what is truly relevant. And so you find, for example, 10 different very similar tomatoes, but you know that the second one is much cheaper and is local and fresh, and the first one is imported, expensive, and looks creepy. Maybe it's also some sort of a context. But from the text similarity, it's like you're searching for tomato and you have a product named tomato. Perfect match. But the second one is much better as an e-commerce product, but you cannot really easily mix it into embeddings. That's why you probably have something for ranking. It might be some old school learn to rank, or it can be some more modern neural network rankers. But still, it's a post filtering, which is applicable only to small amount of search results, but also with all the document features you have, like conversion information, I don't know, popularity, price, inventory availability, and so on.
Right. Okay. Well, look, maybe my choice of the word smart was not really good here, because I can appreciate some things are actually getting in the way, like this semantic thing you said, right? But let's forget maybe the actual effect of whether it's like positive or negative. I still believe that finding things that are semantically close is like on the smart end, right? So another bit, I can imagine probably the multi-language support is going to come almost for free, or for
surprisingly, yes. So a short story about the company I work for. So it's Delivery Hero. You don't probably know the name, but if you in Europe, probably you know Glovo or maybe Talabat. That's like if you use search in Glovo, you're using the model I made. So it's like an umbrella company of many company brands across the world. So in Europe, it's Food Panda or Foodora and Glovo. And we deliver food, and we did a couple of experiments with our semantic search. So it was an issue with the long tail queries. So we pick originally some sort of an open source model, made a couple of experiments. It lacked context, like ketchup and tomato, you know. And then we fine-tuned it for a data set we had. And as the original model was multilingual, it was kind of multilingual because the original transformer model was multilingual.
Right.
It was trained on a mix of English and a little bit of Chinese and a little bit of other languages, but it was still major chunk of data was coming in English, and our search is kind of biased towards English. But surprisingly, so we operate not in all the markets, and not all the languages are used across the board. But surprisingly, when we got a first like demo deployment and started tinkering with it, the first thing people started using is like, what if I search in Arabic inventory using Hindi?
Okay.
And surprisingly, it worked. I like, whoa, cool. And I tried Russian and
Obviously, we planned for that, yeah.
Yes, still, but it still works. And so this model it's not performing as good as in English, but still the level is still impressive to showcase. So, for example, we also recently acquired a company in Korea, like in the South Korea, not North Korea. So there is a Korean language, and there was like, okay, can we showcase what can we do with Korean? And I just took and Glovo up and copy pasted from Google Translate some like pizza in Korean, and it worked. And like, okay, we already have a demo for them. Can we show? So it comes kind of as a side effect of the model being multilingual itself. So it knows that, okay, there are some different names, different words for the same entities. But of course, if you fine-tune it on a specific language, it will perform even better. But if you don't, it's still okay.
Right. Any other freebies from the fact that it's coming from an embedding model or LLM?
People also think that embedding models as neural networks are wonderful at fixing typos and mistakes, and they are actually not. So it's more like I think it's more like a myth. I mean that you need to try. So you need to find some sort of a search engine which is I don't know. You can take Glovo, I don't know, for example, and start writing their queries with errors. And it's not a problem of a search model itself, but a problem of approach, how modern neural networks operate, see texts. So they see not letters, but they see subwords. So
Like
there is a tokenization problem. Tokenization pass before your text is converted into a set of numbers. And this tokenization is not a letter based. Like if you ask ChatGPT how many are letters in strawberry, you might get very different answers, and they're not matching like the number you expect. Because for LLMs, it's quite hard to rely on letters because they have never seen letters in words, they've seen subwords.
Yeah,
So
look, that makes sense. But aren't the embedding models supposed to kind of converge, as in like misspelled words sort of should produce the embedding similar to their correct counterparts, or is just
it depends on how you train, but usually embeddings are trained on clean data to get more context, so they haven't seen any typos. At least they saw not much typos. And that's why usually you might get very weird search results when you just miss a letter. For a person, it's obvious. For a neural network, it's not that obvious because before that, you're searching for pizza, it's a single token. You drop I, it's pizza, and your tokenizer, like, I haven't seen this word ever. Let's split it to p, and a, for example. I don't know. And then neural network need to figure out what you actually meant. And usually when you ask LLM to work outside of its domain, it might struggle. ChatGPT doesn't have like outside of domain, but search models are usually much smaller, so they don't behave like ChatGPT. ChatGPT can be okay with typos because it's seen a lot. Embedding models are usually constrained in latency, and they struggle.
Right. So look, you mentioned this a couple times already in terms of fine tuning, training, and everything. So like, is there like a separate process to train the embedding model that you start off and then fine tune? Do you just train it in some very weird way for search, or I don't know, you take the public model, remove extra heads, and just call it the embedding model for search specifically? I mean, what's the process in general?
So usually there is an MTEB, Massive Text Embedding Benchmark leaderboard. It's originally started as a way to have an objective measure on how different models behave, but then it became a metric everyone tries to optimize, and then it became like this pissing competition. But you can take any model out of this leaderboard you like and which is okay to be used in your use case. I mean, from license perspective, not all of them are like okay to work in. Some of them are like non-commercial licenses. Like if you want to use us commercially, please come and pay, which is perfectly fine. But you can take some like not like public models from, I don't know, Microsoft or whatever, which are fine to be used commercially, and you play around with this model as is. If it works well for your use case and the quality is fine, you just say, okay, task done, go to the next one. But it all depends on your, I can say, how search is important for you. So if it's you're doing something, I don't know, like CRM, and search is not directly generating money for you. So it's like a nice feature to have, but if your search is down, it's not a disaster. If you're doing e-commerce, usually search is generating, it's hard to say, but it can be like from 30 to 70% of your revenue. And if it's down, like it's directly generating revenue. If it's down, you won't get money. If search is down on your CRM, it's like you get money for your CRM like
Anyway,
for the whole year anyway, and it's like a nice, just an inconvenience, but people will survive, and you won't lose a lot. But in e-commerce, you will lose a lot. So you really care about the availability, and you really care about the amount of money you generated out of that, because you have creepy search, you have bad conversion rates. If you increase your conversion rate a couple of percent, but on a scale, if it generates half of your revenue, a couple of percent of improvement can be a ton.
Right. No, that's fair. Okay. So all I hear is basically there is no readily available silver bullet. Whatever is in there might work well for you, but your mileage might vary. And if you specialize in search in any shape or form, being a search company, e-commerce company, whatever, you are better off training and dedicating like resources to that, right?
Yes, but I think it like all the vector databases and all these modern approaches to search came back to the roots of what is relevant, what is not relevant, and like just understanding how your search works. So to get this metrics, like how your search works, you need to actually have some labels, like in the machine learning perspective. So, okay, for this search query, this document is relevant, this document is not relevant. And you need to have a way to reproducibly rerun your search quality evaluation suite to see how your changes to search impact your metrics, this offline evaluation metrics. Is it getting better? Is it getting worse? Are you getting more search results? How are they more precise or not? So, and usually you should, by improving your search, you should probably start with metrics and see what can you do with the search you have right now. Maybe it's already almost perfect. Who knows? That happens. Maybe you can just put a general purpose embedding model from Hugging Face, and it will also be already quite good. So if you're searching for some, like a document management system, I don't know, or some enterprise system, and you have a couple of hundreds of labels, and you see that your search results are actually good, you can just say, okay, I'm done. We don't need to fine tune, because for fine tuning, you can't just get through fine tuning with a couple of hundreds of labels.
Fair.
You need to have tens of thousands, and a couple of hundreds you can do manually in a day. Tens of thousands you can't.
No, just need more people, you're right, and still can do it.
Just let's hire 10 people, and they will spend half a year labeling, and no problem.
Hire 10,000 people, and they're gonna do it in a second. It's gonna be quite a feat, I think. Okay. Look, so imagine I run a company and search is somewhat critical, and I tried the, off-the-shelf embedding model, and they work, would like to improve essentially, right? And let's say I'm a medium-scale company, so I'm not Google, but I have, hundreds of thousands of documents, right? Apart, obviously, like the labeling procedures and whatever, I can roughly estimate based on the size of my data set and how complex the documents are, right? What would I expect in terms of the training costs, as in how much hardware would I need? How much time would it take? Is there like any rule of thumb? Again, I know that it varies from case by case, right? But just to understand the scale of this whole preneur, let's put it this way.
So, everyone, so in this delivery here, it's all already public data, because I already shared these numbers on a couple of conferences. I even have a formal approval to share that. So With the first proof of concept embedding model we fine-tuned was fine-tuned on a single desktop GPU at my home in 1 hour.
That's not bad at all.
Yeah, so okay, but I have yeah. Yes, and it on the first run it generated like 30 million of extra revenue. So
That's good.
I can buy a lot of GPUs if I get this money, of course, because but fine tuning, usually the actual hardware for fine tuning is not expensive. You can, in theory, fine tune on your MacBook. It's gonna be slow but reasonable. The problem is training data. So you need ballpark tens of thousands, better hundreds of thousands of labels. Where you can take these labels, that's a good question. There are two approaches of having these labels. Apart from hiring an army of low-paid people in some low-paid region, you can use your customer transactional data. So you know that if you're doing e-commerce, you have number of impressions per document, you have number of transactions per document. So in some cases, you see that for a query of tomato, ketchup has a lot of impressions, but almost no transactions. So we can assume that it's a negative example. If you have a tomato and there have a pack of fresh tomatoes, half a kilo, and you have 1,000 impressions and 800 transactions, that's definitely a positive. So we just did a bunch of heuristics about like a confidence level, because if you have two impressions and one transaction, doesn't mean yet that you have 50% conversion rate. But at the end, it was just a bunch of heuristics to filter out like a vivid examples of what is relevant and what is not. Went through like this 1 hour round of fine tuning, and it just adjusted, it incorporated a context of the company on what we actually sell into the neural network. So it was already knowing quite well that, okay, for tomatoes, I'm interested in vegetables and not in ketchup, not in sauces or tomato paste or something. It should be purely vegetables. And you go over like tens of thousands of queries, hundreds of thousands of products this way, and it works quite well. So because embedding models are usually tiny, like 100 million parameters, 300 million, maybe 500 millions, what I see in production usually. So people in academia, if you go for this pissing competitions in MTEB benchmarks, you'll see that there are bigger models, but they're not that much smarter considering how slow they are.
Right.
But
Fair.
if you have a training data and you have time and luxury to spend this time on this topic, you might get wonderful results. But people usually struggle with this type of data. So before coming to delivery here, I was working in trying to do a startup on personalization, and we were doing a personalization service, open source, and we got quite a lot of some natural demand. People were coming, just cold coming to your website, clicking a form, contact us, and contacted us to help them. And we come and asked, okay, let's do personalization. What data do you have? And they're like, what data? Like, no, but do you collect, telemetry from your backend? What was shown to the customers? What about transactions and so on? And they were like, no.
That's why we came to you, right?
We should, right? And we're like, yes, you should. And instead of implementing personalization for them, we were teaching them how to set up analytics for their e-commerce store or some other company. And at the end, we decided just to shut it down completely. So I can't say that it was a big success, but I learned a lot.
Okay.
But the issue
Roman,
yeah.
Sorry for interrupting. May I get back? So for search as well as for LLMs, data is a king. Not model size, no compute power. no resources, but the data itself defines how well it's going to work?
I think it's two different vectors of improvement. You can improve on your data, you can improve on your compute. You can improve on both.
If you're lucky enough.
If you're lucky enough and have money, so why don't? But if you can improve on both, you'll get the best results. So I can't say that data is the only king. Compute is also king, but currently I can't say that scaling compute scaling compute is an investment, and you have like a return of investment, and at some moment it gets negative. So you can have a giant model running on a GPU cluster that will cost you a fortune, but increase in conversion rate won't justify the hardware.
Makes total sense to me. Let me circle back to one item you already mentioned. I have slightly related thing. Like we talked a little bit about multilinguality, and this is the part which comes out of the box like almost for free. But what about multimodality? What if I want to search by images?
Multimodality is I can say that there are multiple approaches for multimodal search. So you have a modality of text, you have a modality of image. You can search over just text or images. You can take image and describe it with a vision model, like collapse modality into a text. Okay, that's a product name. And by the way, on the image, that's what we see on the image. Maybe some writings on the packaging, description, what I see, maybe contents or some signs. Or you can search for both. And these are three absolutely different approaches. And I can feel that there are some multimodal embedding models, but models, which can consume not only text, but also images. So but they are like it means that they can take either one modality or another modality. So if you want to search not both, that's kind of the trick.
So okay, you're just like changing a lot in my world picture now, right? Not that it's settled, but so you're telling me that the embeddings that the model gets from the image and the embeddings that it gets from text are not exactly in the same space?
They can make them in the same space. They are in the same space. But if you wanna, but usually if you come from e-commerce, you don't only have images. You only, obviously have text, and you want to search for over text and images. But then you have multiple embeddings per document. One coming from your text.
That's where it doesn't click for me. I thought that once you got the embedding space, basically implicitly defined by your model because it was trained in a certain way. I thought, and I now understand that I'm probably wrong, that getting the model, showing the model an image of, I don't know, a shoe and telling like black shoe would produce semantically similar results. But
yes, it is. I mean that it might be semantically similar, but if you have a document writing black shoe and a photo of black shoe, they are going to be close, but not exactly close. So you will get multiple embeddings per document, and you still need to do some tricks.
Use them somehow, or to basically say, look, there is like few shards of information, like that's the photo, that's the textual thing, and that's, I don't know.
You can, but it makes things a bit more complicated, and I haven't seen much of a success stories that people fused them and it became better.
Right.
But technically, yes, they are aligned. You can, take an embedding of a black shoe as a text, take an embedding of a black shoe as an image, average them, for example, or concatenate, or whatever. Concatenate you want search. Then you just average them and search over it for a query, and it will probably work. But some anecdotal evidence from my friends who tried to do this say that it's not like dramatically improving situation.
So basically, correct me if I'm wrong, like I'm still processing. Like I'm not that fast as you guys are.
No,
Like my model is smaller. Let's call it like that. So basically, to get better results, it's easier to get all the images through some kind of preprocessor, which will basically tell what is on this specific image as a text and operate over this text, like show it black shoe, convert it to black shoe text, and search over text rather than trying to search over both modality spaces.
I think it depends, and there is no single right answer. So you need to measure with your, relevancy labels. So in one case it might work, in some case it might not work. So I was working in another company it was like a plugin for Shopify to do some smart search, and the majority of customers were fashion. Like not the majority, but I guess around a half were from the fashion industry. And we tried to experiment with early versions of this multimodal models and trying to describe images. But, it's not... so usually if you put two red dresses through the model, it will tell, these are different brands of dresses, but they look kind of the same for a neural network. They're different, their style is slightly different, but it cannot see enough differences to justify that this is more relevant than another one. So like, okay, woman, red dress, open neck, I don't know, that's it. It cannot see through it and say that, okay, it's like a specific type of dress in this made based on some historical figure used in some special occasions. Is kind of too tough for search models because they're tiny.
Yeah, I was actually gonna ask, and I believe we cannot really remove the modality from the model. So if we use the multimodal embedding model, Jesus, that's mouthful. If we use that for indexing, we're also bound to be using that very same model for search, right? We cannot just say, okay, for search, we are not supporting image input, so just give me like this tiny slice and, that's all I need.
The majority of search models don't have second modality at all, so they're just pure text, so you don't have this.
No, I understand that. I mean, like theoretically, I could take.
But yes, you can.
Oh, you can.
You can ignore the modality and use it as a dummy text model, but usually people tend to switch, go vice versa. They start with text and try to introduce extra modalities and find out that the majority of models are not multimodal.
Right. No, look, then it's not that bad. I mean, you can take a model that is like good at both modalities. You can index your document database, whatever, and then during search, you're just gonna turn off the visual modality or the voice modality or whatever, and just use the text for search. Sounds okay.
Yeah, we in delivery here we're experimenting with just folding these modalities. Okay, we have a picture, and you use this picture description only once and purely offline. So you don't really care how long does it take. Yeah. You just, 1 second per image, no problem. You just keep it running for a week. And at the end, you got all these image descriptions, and then you just use them as an extra field. So when you make an embedding, you use product title, category, some top-level category. I don't know what you have about this item, and also like a textual description what's on an image. And this textual description can be controlled with a prompt. So you have like a beefy vision models, I don't know, with just ChatGPT, paste a picture to ChatGPT and ask it make a SEO optimized, like search engine optimized description
Describe the
of
image,
what
basically. Yeah.
describe the image in this SEO. That is it from the keyword perspective. The SEO optimized is like, okay, I got it. I saw a lot of SEO optimized text in the internet, so I know how to write it, and this will spit you a wonderfully handcrafted, full of keywords description. That's what you actually need for your dummy and stupid small embedding model, because
Right.
it cannot extract a lot of contextual information because it's so small. But if you help it with expanding it in a semi-synthetic artificial way, why don't? It
Okay.
can be seen like a distillation in machine learning.
Fair. Okay, let me quickly summarize here, because we sort of naturally started talking about the challenges of the search, right? So we have mentioned, we just talked about the modalities, obviously. Okay, that's a fair challenge, and that's I would say it's multi-angular challenge even, right? So we briefly mentioned the size of the models. I think we will talk a bit about that in more detail, but TLDR is that for search, especially for serving real-time search, we need the models to be relatively small. We cannot afford multi-billion parameter models, right? And obviously it depends on, how many H100s you bought or whatever you bought for your company, right? We mentioned that evals are hard. And again, that's natural, because depending on what you are searching, what are your KPIs, it might be difficult to define what is a good embedding model, was a bad embedding model. That's all fair, right? Is there anything glaring that you guys look after, or maybe like in general, what is considered like, the big problem with search?
Data, Anton, you forgot the data.
Yeah, data.
Itself
I mean,
defines the search.
garbage in, garbage out, as we say, right?
Yeah.
So that applies to everything. Yeah. Anything
So
worth mentioning in terms of like, okay, this is something we got to take specific care of when it comes to search, obviously.
For search, I can say that there are some other approaches to doing search which seem to be popular, not like gaining some popularity. So the first one is that why should you use actually embeddings if you can use neural network to do query expansion? So you can ask ChatGPT, okay, for this document, what search queries might be used to find it. And it will generate you a bunch, and you just put them in Elasticsearch as a separate searchable field, and it's gonna improve your search quality quite a bit. It depends, but like general understanding how it works. There are search expansion models like SPLADE. Elastic has their own commercial one called ELSER. But the idea is that if we have a lot of data sets with labels, what is relevant, what is not, what if we train a specially handcrafted neural network like ChatGPT, but it's trained on a specific challenge of expanding your documents with relevant keywords. So for a specific query, these documents are going to be found higher in the list, and the relevant documents are going to be found lower. So it's not just some expansions, but expansions will yield to better search results based on your data set. But the cool thing of this embedding models is that, well, not embedding, these expansion models, that you can apply them offline purely. So you just expand your documents with some extra keywords or extra, like with image descriptions. You expand your documents with an image description, put it in your field, no embeddings, no neural networks. It's just good old lexical search, but you got a better quality in search. And at the end, if you're a commercial company caring about conversion, you don't really care, is it neural network or not, if it increases your sales.
Okay.
There are some other approaches called late interaction and ColBERT, which are based on an idea that a single document might... So if you have a long documents, you can have an issue with So embedding is like a compression of your document into some amount of numbers. If you have a long document, like, I don't know, 10K tokens, and a small embedding, probably you will lose a lot of detail from this document. So you might assume that, okay, let's just have many embeddings per document, maybe even embedding per word, and do some smart magic during retrieval to fold them in a way to get some context out of this document without losing the details. It's also a nice approach, more computationally expensive, but better use case for long context document retrieval. But in e-commerce, it's not widely used, I can say. So, and at the end, re-ranking, and you can just have a top 10 documents and you can put them into ChatGPT. And if you have enough of H100 to do real-time inference, you can just ask it what's the most relevant one. And like large LLMs can be fast enough to be run quite quickly if you don't overuse their context length, and can get a lot of like fine-grained information from your query and from your documents. You don't need to use actual LLM as a re-ranker. There are some special handcrafted LLMs, so you don't need to describe them what you want to do from them. They already know that they're built to re-rank, and you can use them. So it's not all about embeddings. But like, to summarize.
Right. Okay.
May I ask one silly and stupid thing, as I usually do? Like, somehow this all reminded me early days of like chess programs, when there were no good winner, there were no perfect strategies, they were very, very naive and straightforward, but there were several like different approaches. And what was interesting for me when I read about it, that at the very beginning, there were no good winners. So the good winner was a combination of different approaches. Basically, the same chess game was fed to different algorithms. And if two or three of them, they agreed that the next move is that, this is good. But if they diverged, it needs to be like chosen. So for search, I'm seeing the same analogy. Like, for most cases, people, they don't need one perfect result. They need top 5, top 10, something like that. What if instead of bringing like extremely expensive big models, we will bring like 2 or 3 smaller ones and only bring results which are relevant for like 3 searches? Is it like stupid or just stupid?
The irony is that all of these embedding models from MTEB leaderboard trained on the same amount and set of training data. So most probably you will get exactly the same, maybe slightly different relevancy labels, like scores of relevancy from different embedding models. If they were different approaches, probably yes. But if you go for different models of embeddings,
I will get the same top 10 with different like ranking numbers.
Yes, slightly different rankings, but probably the results are gonna be almost the same. If you see the leaderboard, you see that it's all of them are like top 10 have exactly the same looking, like it's like second digit after comma difference.
Okay, makes total sense.
Yeah, but if we circle back to chess programs, what happened actually with like a first breakthroughs in this area when chess programs started to be much smarter than humans, when chess programs started to be trained on the games of each other. So it's more like a reinforcement learning. So instead of just observing how human label feels, like how human behave, they started to play together with each other and then just learn out of mistakes of each other, and their like elo score went to the sky. With search and with LLMs, we're coming through some sort of a Wild West here, so it's not yet happened, but in the last couple of weeks, there were a couple of papers published in this area. So instead of just asking neural networks to memorize what is relevant and what's not, what if you introduce an intermediate step to do some sort of like a self-evaluation? Okay, that's your search query, how you can expand it in a way to make your test evaluation better. So you like stop the training, go into inference mode, you literally do search, like you search the query over that, you see like is your NDCG score, like search quality metric, increases or not increases, like DeepSeek does for coding. And then you pick up the best variation and say, okay, that's a nice behavior. And you guys who expanded this query not as nice as this, you are bad. You don't get any reward. This behavior gets reward. And then you do it like sequentially many hundreds of thousands of times, and your model improves dramatically. So if like there are a couple of papers and ranker models released, and it was like a huge jump in all these leaderboards. People still do this listening competition. So, but these are very early models. So industry will just sit probably and wait until first brave people go and measure, is it really better or not?
So probably like 6 months, a year, and we'll get better search.
I believe that yes, but also it's a question of what you can. What's your baseline? So you'll get better search if you got bad search before, you just swap a model and you got better search. Yes. If you already spent 10 years improving your search in an old way and then you got a new model and you compare, and yes, it's performing worse than your baseline. So like, for example, in Delivery Hero, we fine-tuned the embedding model in our use case. And yes, there are bigger models being released. We from time to time do evaluations on our own internal data, which is not leaked to the public. So, and we see that still our very stupid fine-tuned embedding model performing better than non-fine-tuned but smarter model, because it knows context, and the smarter, bigger model don't.
Look, we've seen that before. I vividly remember times of when I think it was the fine-tuning on OpenAI was only available for GPT 3.5 when the GPT 4 was out or something like that. And apparently fine-tuning GPT 3.5, although it was, well, let's be honest, retarded in comparison to GPT 4, fine-tuning that on a specific data set actually skyrocketed the performance so that it outperformed GPT-4. And for many use cases in the industry, it was like very viable because it was cheaper. It's like a simpler model, it's a faster model, and so on and so forth. But
yes, you need the training data, and no one cares about collecting it. That's an issue.
Yeah, well, garbage in, garbage out, right?
Yes. But like from product perspective, it's like baseline matters. If you have, I don't know, synthetic score of 10 and our new model gives you 40, it's like, wow, tremendously good results. But if you had like 88 and new model gives you 88.2, does it worse? Does it change? Probably not.
No, so for some novel GRPO-based ranker model, so there is an NDCG score. It's like a number between 0 and 1. 0 is like an absolute random, and 1 is a perfect ranking. So your relevant document is always first. If you have multiple, they're all on the top. Mm-hmm. For ranker models, for cross-encoders, they're all somewhere around 62, 63, 0.63, and newer models giving you 68. So it's not like, 90 yet, but still a nice bump because they were going from 60 to 62 for 2 years. And now it's like you go from 62 to 68 in like, okay, DeepSeek paper published, and probably people dropped their shit and started training these downstream models with this new approach. And in a month or two, you got a jump like you didn't have for the last 2 years.
So basically, there is a room for improvement, and speed is increasing.
Yes, so usually in these leaderboards, all this improvement were coming from scaling the compute. So, okay, there are bigger players coming, they can afford training longer on a bigger clusters, then you eventually get better models. But the data is the same for training. So for embeddings, you need to have labels, and labels are extremely expensive to get. And at the end, if you spend long time enough going through the internet, you collect all of them, like Pokemons. And all these companies doing embeddings, they already collected exactly the same set of training data bits from the internet. So they train on the same data set. So the who has the bigger cluster wins. But then you got DeepSeek with this new approach of reinforcement learning for poor, which is like so damn simple that you can like do it at home. And boom, we got a nice improvement.
Oh, nice. Okay.
Probably if Google invented this in 2025, they won't publish it.
I might be completely wrong here, obviously, and biased by my background, but I think that the improvements on the model side, again, because they're coming from research, academia, and experiments and whatever, they're going to be coming, probably, hopefully. Like, we all want to live in a better future, right? But this is just part of things. There is like another part of the stack, which is where we store all these beautiful embeddings and the documents and whatever. And as far as I understand, there is also like a bit of a specifics, right? So if we roll back to the, like, let's name it like the toy setup of search, where you have the embedding model and you have the documents indexed by whatever embedding model you are using, and you just want to do the similarity search. Let's say you're not using the ranking model and whatever, right? So you mentioned everyone has it right now, right? As in, even like MongoDB and whatever. But if you were to build a more or less production-ready solution, what would you choose? Is there like any go-to player or players? Like, if you choose a relational database, you can go with Oracle or MySQL or PostgreSQL. Yes, you can go with SQLite in specific scenarios, but it's probably like less versatile, right? So what happens in the embedding space? Is there like anything that you would say, okay, just, you're not going to lose your job over choosing, I don't know, Pinecone for embedding search or whatever?
I got the impression that elephant in the room is Postgres. Like no one notices Postgres and PG Vector.
But elephant, right?
Yes, literally elephant in the room, yes. And a couple of Hacker News discussions, there were like discussions about, okay, what you use for your embedding search. And everyone's like, okay, we tried specific databases, we tried search engines, but we already have Postgres running on RDS on Amazon or in GCP or on any cloud.
And that's all right?
And like, we put embeddings there and it works. And like, why should we have another database running on the side just for embeddings? Yes, it's easy to outgrow Postgres. In some cases, it might get very expensive. It might get slow in some cases. And then you need to move to something bigger and more complex to maintain. But if you don't know where to start and you don't want to mess, you probably should put everything into Postgres and call it a day. Right. If you feel that it's not fitting you have some issues, then you will have an understanding why it's not fitting you, what are you looking for, and what are your requirements.
Okay.
And just go for it.
I have probably simplification. If you're asking what kind of tool to use Postgres. If you're smart enough to outgrow Postgres, you're not going to ask this question.
No, you're going to figure it out.
You're going to ask this question, but like, okay, I'm using Postgres, but my latency numbers are too high for this type of query. It seems to be working not that nice. I want to have quantization. I want to have some, I don't know, some crazy queries running on top of that, and it cannot afford, does not allow me to do it, or it's about costs. So probably you will figure it out by yourself, but I can do a shameless plug finally. So I'm also doing some sort of a search engine, but I'm not trying to say that everyone should use it. So because probably you need to be mature enough to start looking for alternatives for your current solution. And it's very hard to outgrow Postgres on some basic use cases, but in e-commerce, it's usually not only about just vector search, it's also about operational complexity. So all current search engines like Elasticsearch and OpenSearch and Solr, Qdrant, VV8, they say that they are databases. And if you run database in a cloud and you do self-host it, probably it's a major pain in the ass because there is a state inside. You can't just shut down a node and then your data will disappear. So you need to have backups. It's hard to scale up, scale down, and so on. Also, you might, so it's a database, so you need to do all your inference embeddings somewhere outside. And if you want to
run vacuum in Postgres, yes.
You need to run vacuum in Postgres. You need to do ranking after that. So I'm currently doing Nixiesearch. It's like an open source competitor to Elasticsearch, which is also kind of open source, but not completely. So, for example, you won't be able to do advanced ranking there if you don't pay. And a lot of different features are just kind of open source, but they're not. And but it's not only about embeddings and ranking. It's also based on S3. So there is an S3 based backend to store your index. So, and it's not trying to play like a database. You cannot change things inside of it. So the schema is, so probably it's somehow,
I think it's called query engine.
Yeah, it's more like a query engine. So, and in e-commerce, usually you don't need to have a database inside of your search engine. So yes, you need to be able to add documents there, but you're not gonna change your schema on your production just during, live traffic happening on there. So probably what you usually do in Elasticsearch, that you either create a separate index, do all the modifications, re-index everything manually, and then switch the traffic. But still, what's the value of being able to change the index structure right now and just break everything? Or having the same cluster handling the same indexing and search load. So you have search queries coming from real customers, and now you need to reindex your 10 million documents. And you're like, whatever, I'll just throw them to your cluster and it just dies because it was overloaded, or your latency goes up. So it should be, the idea of Nixiesearch is that, okay, we have a separate indexing. It's just at the end writing parts of the index on S3, and your searcher just picks these parts when they're ready and executes search queries. Then you have no state inside of your cluster. Your nodes are stateless. You can kill them. You can do whatever you want. You won't lose an index because it's just a directory on S3 bucket. And index schema is immutable itself. So it's defined on a config file, and you cannot even have a way to change it without like reloading the engine. So then if it's on a config file, you can do your favorite GitOps style management of configuration in Kubernetes. I don't know, you just change a config file, do a rolling restart, and that's it.
No, look, it makes sense. That's similar to that. Basically, what you're describing is a separation of storage and compute, holy grail of any analytics database. If you don't have it, you're not really.
Yes, but search is not analytics. It's a little bit different use case because analytics is not latency sensitive. At least it's not as latency sensitive as an analytics.
Different requirements. That's correct.
Yes,
I'm
in search you need to be very careful with latency, especially if you have remote storage.
Right.
But at the end, we're not the first trying to do search on top of S3, but we decided to go a short way and just use Lucene for search. Mm-hmm. So unlike, I don't know, a ton of different startups saying that, okay, we do search on top of S3, they cannot do, facets, like complicated filters, a million of different optimizations made by very smart people for vector retrieval. They need to re-implement everything, probably in Rust. Because, like, if you do a startup, you do it in Rust. And we're just piggybacking hundreds of many years of investment in Apache Lucene, but just having a different way of operating it. So there is another storage layer for block storage, and there is another way of managing indices. So it's not like you post some JSON to your production cluster, some magic happens, and sirens scream and traffic stops and so on. You can't. So the idea is that you can't do stupid things with Nixiesearch. So it's very predictable in behavior and hard to break.
Okay, CS one-on-one question. So when we are talking about vector search, because it's essentially like a tuple of numbers, and we need to compare a weird metric like a cosine similarity or something like that, is there any structure that accelerates those searches, or it basically boils down to just iterating over all the vectors and finding the best?
Surprisingly, it depends. there is a data structure which does it, and not even one, like HNSV and ANN style of indices, which are like CS. Not one-on-one, but more like one or two. Is like 2-on-1 is like you probably know what skip list is. So it's like you're navigating through some long jumps, and then you go down and do a smaller jumps and navigate down and do a very small jumps. This is kind of the same, but imagine that you're not having a skip list, but like a skip graph.
Okay.
So that's it. So you can navigate not just left and right, but you can navigate in any dimension, like in this graph. And so you start with some entry point, you do some large jumps in this cosine space to find something close to it. Then you go down a layer and you got smaller jumps in this space, and you go down a layer, you got even smaller jumps, and then you just do fine-grained comparisons. So some sort of an index.
Right.
And usually what it's implemented almost everywhere. It's in Lucene, it's also there, and it's quite optimized, I can say. Maybe not the fastest ever implementation, but at the end, in practice, your retrieval takes 2, 3, 5 milliseconds, maybe 10 milliseconds in practice. But you have embedding before that, which also takes like 10 milliseconds, and probably you have a ranking which takes 100. So it doesn't really matter that, okay, you're saving 1-2 milliseconds on retrieval because you are written Rust. If you have a giant ranker after that, which is just eating all the latency.
Right. But look, I was actually asking very practically because since you mentioned there are like ways around the problem. By ways around, I mean Postgres plus PG vector, right? ClickHouse fanboy right here. I think you were in the same Telegram group in ClickHouse.
Yes, but I'm not posting there for quite some time.
Right. Yeah. So look, the point is ClickHouse is technically like an analytics database, right? But it's really good at grinding through like gigabytes and gigabytes of data for reasons. We're not going to dive into them right now, right? Or would it be feasible to just offload all the vectors in ClickHouse and piggyback on the fact that it can iterate through data really, really quickly? Or
I mean, that probably it also uses something like HNSV, and in practice, you'll get very similar latency. If you already have ClickHouse, of course. If you have Postgres, use Postgres. So latency is not a big issue right now, unless you have 1 billion of documents.
Right.
But,
No, look, I'm thinking more about the fact that ClickHouse is a columnar database. You might get some benefits in there, especially if you have multiple embeddings and you want to search over one of them.
I haven't measured ClickHouse on this latency, but at the end, it's all these HNSV implementations in the industry are already quite well optimized, because it's also some sort of a pissing competition between different vendors of vector databases. Like, okay, we are faster. No, we are faster. And we're not even publishing benchmarks because we're afraid to lose, and so on. And eventually all this HNSV implementations have like an important limitation that it's a lot of random reads. You need to read some, so you're navigating through this giant graph, and your documents are quite heavy. So these are like really real embeddings. So it needs to be in RAM. Like it can be spilled to disk if you have a very fast disk, but if you care about latency, you shouldn't. You should keep them in RAM, and at the end, it doesn't really matter how you implement your in Rust or in C++ or in Java, because at the end, you're bound probably by memory bandwidth and not by compute.
Well, again, turning back to ClickHouse, there is still thing to optimize, right? Because you can store things compressed in memory and just decompress on the fly. And in some cases, it's actually giving you the performance increase, because decompression algorithms like LZ4, for example, are extremely fast at decompressing. They do it faster than you read
The
from
issue
RAM.
that embeddings are not compressible. They are already a result of compression.
Yeah, that's fair. Yeah, it's actually like a random data. So yeah, it's probably
not like purely random. You can compress them for a couple of percents, but that's it.
Yeah, it's not worth it. Yeah, fair. Okay, look, you did mention a few things already. Like, I mean, obviously the best database in the world, which is your one for that task. The Elasticsearch and other names came up, right? Is there any, like, I don't know, like an edge almost or benefit of using a commercial solution versus using open source? Because I assume there are plenty. I mean, Postgres is like fully open source. Is there any reason why you would go to a commercial vendor now in 2025? And like, do you think it's going to hold, or what's the status quo basically right now in terms of like open source versus closed source commercial things? Let's just like not touch hosted solutions, because I think it's a different angle, right? You can debate whether you want to use a hosted Postgres version versus self-host, blah blah blah, out of the scope. Just the solutions themselves. What's there basically?
I guess it's costs, because if you use Pinecone, for example, it's like sounds like serverless. They do have different setups, like you can have like hardware allocated for you or can go for serverless, but people usually want to have some sort of an endpoint to play with, and this paid solutions seem to be quite a nice fit. I also once checked some sort of a financial reports of Elastic and Pinecone, and they have also very similar number of customers. But surprisingly, an average check for Elastic is 100 times bigger or something like this. I can't say exact number, but like people are paying Elastic much more, and Pinecone is just a couple of hundreds of bucks. So that's kind of limits the use case, I guess, because people, when they feel that they're paying a lot, they might want to have control, and they tend to switch to something they can control. Maybe hosted solution. Okay, like the majority of all these vector databases are open source, but there is a cloud version, which is hosted version of this vector database. And if you are an enterprise, like we're doing e-commerce search, why don't you just
outsource the headache?
Outsource the headache of maintaining it, because from return of investment perspective, it might be cheaper to pay them to get just a hosted version.
That's why I said that hosted versions are out of discussion, because it's a never-ending tail and very, very specific use case by use case, right?
Yes, but usually it's worth it, because these people selling hosted versions of vector database are not stupid. So it's like price it in a way to be kind of more kind of cheaper than you'll just hire an engineer and pay this engineer to work on that for a year, for example.
So what's your forecast for future? Where everything moving?
So I think it like common sense wins, because all the search industry slowly coming back to the roots that you need to understand what is relevant, what is not, instead of just getting a bigger model. You get the same of sense while switching from GPT 4.0 to 4.5 to 4.1 to 4. Whatever, because they look the same. So it's not about the size of the model and how much money you invested into the training, but more about the data, what is important for you as an enterprise. So relevancy is subjective, as I said. So eventually you need to understand what search needs to be for you, for your particular use case, what's relevant, and then go from that. Maybe you can have bigger model if it solves your pain. Maybe it's not. Maybe you need just to go down, understand that customers are searching something in a very weird way, and you need to just help them finding this. So there are different dimensions of improving search. So like there is a recall thing, like a findability. So you search for some obscure query and you got 0 results. A problem. If you got 0 results, you can't buy anything because you have like empty page. So that's the first case. In some cases, you have a kind of an opposite problem. You got so many results, but not all of them are precise. So you need to focus on precision. Then the relevant results should be on the top, but still you need to go to the roots. And it doesn't really matter which embedding, ranker, LLM you use for that. You need to just understand what you're actually building. And if you can build it with sticks and Excel spreadsheets, why not?
So no one size fit all, and never will be.
Because ChatGPT won't know what's important for your company. Yeah, you can try to explain, but at the end, your explanation is going to be like a book. So we tried in Deliver here, we tried to do these experiments with LLM as judges for search relevancy. We also tried to hire external people like, Mechanical Turk to Loka and explain them what is relevant. And we wrote guidelines. And it's not only us who do this. There are public relevancy guidelines from Google for their set of evaluators. And Google relevancy guidelines are 180 pages long.
Jeez.
180 pages just to describe what is relevant. If you just say, okay, ChatGPT, is this relevant or not? They're like, no, your prompt probably needs to be like 180 pages long. And you need to write it for your particular use case. So it's more like a business problem and less than a technical problem.
Okay, but in terms of the technical problem, do you think there is like a transformer moment sometime in the future where, I don't know, some technology or the algorithm or something is going to come up that's going to basically flip the equation or level the field or drastically change the status as of now.
If I was an investor or like working for a company doing this type of LLMs, I'd probably say, okay, it's coming. We're already cooking it in another room. You just need to wait for yet another year or 2 or 3. We might not know when. Like Sam Altman usually says, like AGI is just around the corner, like like a communism. And but technically, I think it's just organic growth. So even
No. That I understand. What I'm asking about is, do you think there is like a space for breakthrough, right? Because there are certain areas where you cannot really do any more breakthroughs, right? Like, I mean, I might be saying total lies right now, but I think in chess engines, there is not that much you can improve further, right? They're already like very, very good, far surpassed humans levels and so on and so forth. And even if there is a breakthrough, like the very good question is, what is really the point? You're probably not gonna be using that in any meaningful way, right? Similarly, you can argue that, I don't know, reducing certain parameters of chips or whatever might be also like, okay, chips we always want to make faster. It's a bad example, but I mean, you probably get that. It's like, oh, screens is a very good example, right? When the Retina came out on iPhone, everyone was like amazed. It's great, right? But as soon as we get to, I think, 250 pixels per inch or something like that, can you make a display that's 500? Sure. Would it matter? Not really. People can no longer see the difference, right? Maybe there is something like that happening in the search, or maybe there are areas that are just waiting to be disrupted because we can do something much better. I don't know, cheaper and faster, something like that. Is there anything to pinpoint really?
I guess it's just commoditizing, as you described with screens. So yeah, you can make a slightly better embedding models if you train it longer. But if you go to Reddit and see how people choose, they'll just go to the leaderboard, pick the one they like based on a name, and that's it. And probably it will work as good as another model having just a slightly different name and being slightly below or above this model. Right. So it's just conversed into some amount of information you can compress into an embedding. So you either need to scale it up with the size, so it can just memorize more and keep more context in your embedding. Or, of course, you can just go back to the roots and think what you actually building. What's the actual business problem? And here, I'm not sure that GPT or bigger LLMs will help us much, but we have some tools, and these tools, like, for example, fine-tuning. 2 years ago, it was for, PhDs. Right now, you can take sentence transformers and do it in a collab, and it's done. So it's just quickly commoditizing. I think it's the same for search. So while building Nixiesearch, I was thinking that, okay, we need to focus on AI, all this bells and whistles, hype technologies. But while speaking to people, we found out that people are not struggling with embeddings and AI. They're struggling with, observability and shooting yourself in the foot while changing structure of your index and, scaling up and scaling down things which are problematic for ages and probably gonna be problematic for ages. So we kind of shifted towards operations and towards being closer where the pain is and not towards the hype. But so that's my prognosis. I'm more like a pragmatic approach.
I kind of feel for you, and I also feel a lot of respect you guys doing the groundwork, because I also think that, unfortunately, in engineering and software engineering, there are a lot of areas that are just not sexy, right? The deployments are not sexy. The scalability is not sexy. I mean, it's sexy to some people, and they pay much attention to that, but often the part of actually making things work in production, making it maintainable, making it observable, is an afterthought, right? And what really makes products stand out is when you actually pay attention to these things, because it's easy to work on nice and shiny stuff, right? Because it's interesting. It's like it's very sellable. You can put it onto your presentations and stuff like that. But when it comes to actually running in production, much more boring things come up, and many players just ignore that somehow. I don't know why they do it.
It reminds me of this kind of like dichotomy of capability versus reliability. It doesn't matter how capable something is until it's not reliable. So you need to have a reliable solution first, and then capability comes. But somehow everyone doing this kind of like sample picking, telling, oh, I used, I don't know, some kind of fancy model and was able to do that. But this is like one of a million. So yeah, I completely agree. Making something reliable and working stable and being accessible for production makes much more
I can't
sense.
say that NixieSearch is so reliable that I'm proud of, but there are less moving things to break.
Okay.
So it's easy.
We'll see about that.
It's harder to harm yourself with your product.
Yes, because there is no, when it started, it's kind of almost immutable. So you can't just, break it because there is no endpoint to change things inside.
Makes a lot of sense to me.
Okay, so I feel like it's about time to say it's about time, right? Roma, it was a pleasure having you, and quite an interesting discussion, I think. So many thanks for coming.
You're welcome.
We hope to invite you or your namesake soon as well to continue on that.
Not a very popular name, I can say. So
it's okay. It's not like rare, or something.
So you just go to Facebook, put this name, and just randomly pick people. That's how you found me.
Yeah,
LinkedIn. It was
LinkedIn. Sorry, yes.
We are a professional company after all, right? Okay, cool. Yeah. Look, again, thank you very much. Was very insightful. It was a pleasure to have you, and I believe the discussion was also somewhat interesting. Obviously, our listeners are going to tell us more, but apart from that, and without further ado, I can say that is it for today. Thank you.
Thank you, Roman.